back to another new video of pen paper physics. This time we are going to discuss about the sign conventions. But before we go for the sign convention, make sure you have already seen the previous two videos on the basis of this mirror. How to draw the wave diagrams and what are the details, different parts of mirror. So links are given in the description box below. Please do check that videos and then come back here and learn about sign convention. But before you start the video, please subscribe to my channel and press the bell icon so that you can get the notifications whenever I upload the video. So before wasting any more time, let's move into the video. While studying the sign conventions for spherical mirrors, we need to understand and remember some important key points. Number one, the object is always placed to the left of the mirror. That means the left side of the mirror is the real side and right side of the mirror is always the virtual side. Next point to be remembered over here is that the pole of the mirror is taken as the origin. Whenever you are going to measure any distance, you are going to consider any sign, make sure you always start from the pole. And we always take the distances parallel to the principal axis, which are measured from the pole of the mirror. Here I am showing you the representation of the sign conventions through a graphical method. Now we consider the pole as origin. So here also in a graph paper I am taking two perpendicular axes x dash and y dash, and we will keep the P or the pole in the origin. Similarly, whenever the light is falling on the mirror, it is always traveling from left side towards the right side. So whenever any distance from pole going towards the right side, which is towards the positive x-axis, so the distance is positive, and any distance when you are taking from pole and going towards the left side, which is the negative x-axis x dash, we take those distances as negative. So any distance in the direction of light is positive and any distance opposite to the direction of light is negative. The same rule applies for measuring the height of the image and the object. Above the principal axis, that means towards positive y-axis, the distance is positive, and below the principal axis, that means towards the negative y-axis, that is y dash, is the negative distance. Now we will learn some general terms that is used over here. Distance between the pole and the object is always considered as u. Distance between the pole and the image is considered as v. The focal length is denoted by small f. The radius of curvature is capital R. The size of the object is O and the size of the image is I. These symbols you need to keep it in your mind because further in video I am not going to name anything. I am going to use the symbols only. First, we will start with concave mirrors, and the first ray diagram that we learn in this case is the object at infinity. And the image that we get over here is at F. Now here in this video, the first arrowhead is showing you the direction of light, which is from left to right. That means towards right side. So to find the sign for U, we will start from P and we will move towards the object, which is in the opposite direction of light. So U is negative. Here the image is produced at F, which is also in front of the mirror. So from pole to F is again the arrow is moving in the opposite direction of light. So V is negative. Next, for finding R and F, we will take the distance from P to F and C. And this is also the arrowheads are moving opposite to the direction of light. So definitely R and F is also negative. Object is above the principal axis, so the height of the object O is taken as positive, and the image is real and inverted, so we assume the image will be below the principal axis, so the height of the image I will be negative. So from here we can finally conclude the O is positive, I is negative, U, V, F and R. All of them are negative in this case. Next ray diagram is the object is beyond C. In that case, the image is produced between C and F, and the image is real and inverted. Here also first I am showing you the direction of light, which is towards right side, and the object and image is already drawn over here. Again we will take U from P, which is in the opposite direction of light, so U is negative. V is also negative since the arrowhead is moving in the opposite direction of light from P. For radius of curvature and focus, the arrowheads are also moving in the opposite direction of light from P, so both of them are negative. The height of the object O is above the principal axis, so positive, and the height of the image I is below the principal axis, so it is negative. So from here we can conclude that the O is positive, I is negative, U, V, F and R, all of them are negative over here. Next case that we are going to study over here is object is at C. In this case, the position of image is also at C and it is real and inverted. Here also first we will identify the direction of light, which is towards right. To find U, the arrowhead is moving from P towards the object, which is in the opposite direction of light, so definitely U is negative. Similarly, for V, arrowhead is also moving in the opposite direction, so V is negative. And it's clearly evident that for R and F, the arrowhead is again moving in the opposite direction of light, so R and F is also negative. The object is above the principal axis, so O is positive, and the image is below the principal axis, so I is negative. So we can conclude over here that O is positive, I is negative, and U, V, F, R, all of them are negative. Next case that we are going to study is the object between C and F. First, we will take the direction of light, which is towards right. To find U, we have to move towards left, so U is negative. For finding V, we have to move towards left, that means towards negative x-axis, so it is negative. For radius of curvature R and focal length F, again we have to move towards left, so both of them are negative. The object is above the principal axis, so O positive, and image is below the principal axis, so O negative. So here in this case we can conclude O positive, I negative, U, V, F, R, all of them are negative. Next case that we will learn is the object at F. In this case, the image is produced at infinity and it is considered to be real and inverted. Here also in the same way we will take the direction of light towards right side. For finding U, we have to move in the opposite direction of light, so U is negative. For finding V, again we have to move towards left side, which is negative. Since the image is produced at infinity and real and inverted, so it has to be in front of the mirror, though we can't see it. Similarly, for R and F, we have to move towards left, so both of them are negative. In this case, the object is above the principal axis, so O positive, and image, though we can't see it, but it is a real and inverted image, so it has to be below the principal axis, and I negative. So from here we can conclude that O positive, I negative, U, V, R, F, all of them are negative. The next case and the last case that we will learn in case of concave mirror, when the object is placed between F and P. Here the image is produced behind the mirror, which is a virtual and erect image. So first we will consider the direction of light towards right. To find U, the arrowhead is moving in the opposite direction of light, so U is negative. Only in this case, to find V, the arrowhead is moving in the direction of light, so V is positive. Like other ray diagrams, to find R and F, we have to move in the opposite direction of light, so both of them are negative. Also, O is positive over here since it is above the principal axis, and I is also positive since the image is also above principal axis. So here in this case, we can conclude that O and I, both of them are positive, U is negative, V is positive, F and R is negative. That's it for the concave mirrors. Now we will move to the convex mirror. So the first case that we will learn over here is the object is at infinity. The image is produced at F, which is a virtual and erect image. So first we will consider the direction of light, which is towards right. To find U, the arrowhead is moving in the opposite direction of light, so U is negative. To find V, which is produced at F, the arrowhead is moving in the direction of light, so V is positive. And to find F and R, the arrowhead is moving in the direction of light, so F and R is positive. Now, since the image is virtual and erect, so the image is above the principal axis, due to which I is positive and O is definitely above the principal axis, so positive. So from here we can conclude that O and I, both of them are positive, U is negative, but V, F and R, all of them are positive. Next case we will learn over here, the object is at any location in front of a convex mirror. So in those cases, the image is produced between P and F and the image is a virtual and erect image. So first we will consider the direction of light towards right. To find U, the arrowhead is moving in the opposite direction of light, so U is negative. To find V, the arrowhead is moving towards right, that is in the direction of light, so V is positive. To find F and R, the arrowhead is moving towards right, so both of them are positive. And O and I, both of them will be positive since the object and the image is above the principal axis. So here in this case, we can conclude that O and I, both of them are positive, U is negative, but V, F and R, all of them are positive. So what are the important observations that we have noted over here? U is always negative in all the cases. For concave mirror, F and R is always negative, and for convex mirror, F and R is always positive. For real image, V is negative and I is also negative since it is an inverted image. For virtual image, V is always positive and I is always positive since it is an erect image.
Welcome back again. Hopefully you all have seen the video, you have understood and the concepts are clear to you. All the media links are given in the description box below. Please follow my Instagram page and the Facebook page. Definitely you will get the updates over there. Thank you very much for watching the video and hope to see you in the next video. Till then, bye bye.